Theta equals A over R is the formula on your formula sheet. So glad I restarted to get a blue box back. Okay. This is an easy formula that people stink at. Because they think it's easy, they don't remember certain things. Well, theta, the catch with theta, is that it has to be in a specific measurement. Let's talk about this. So theta is your central angle. A is, if this freezes, I'm going to be so annoyed since I just restarted it. A is your arc length, and R is your radius. Now remember I told you I want you to understand things, not memorize. So we know that theta is an angle, correct? So either our angle has to be in degrees or radians, one or the other. Well, let's look at this formula and see what it has to be in. So arc length has to be in some sort of measurement, right? Centimeters, meters, whatever. So does the radius, which is center to edge. Arc length is that arc around the outside of the circle, okay? The catch here is, if the arc length is in a specific unit, let's say centimeters, for example, the radius would also have to be in centimeters. Now, guys, what happens when I have a centimeter over a centimeter? They cancel. So when I'm done dividing A by R, I'm left with a number without units. So I'm left with theta equals some sort of number with no units. Do we agree? So is theta in radians or is it in degrees? It's in radians because it has what? No units. Remember, radians, you don't have to write anything behind it. You could say 8 pi radians. You could say 2 over 3 rads. You could just say 2 over 3. And that is assumed that is radians. So that's why I told you the degree symbol has never been so important as right now. Because if you don't put a degree symbol, what is it your answer in? Radians. So what often happens here is you have to remember that the central angle has to be in radians in order to use this formula. So you're either getting an answer in radians or you're using your answer in radians. And why is that? Because when the units cancel off, I'm left with no units, aka radians, right? So a lot of people try and memorize, oh my goodness, I have to memorize, it has to be in radians. You shouldn't memorize it has to be in radians, you should understand why it's in radians. It's in radians because your arc length and your radius are in the same units, which will cancel off, and therefore theta will equal a number with no units. That can't be a degree, or it would have a degree symbol, correct? So it has to be in radians. Does that make sense? Understanding is way more important. Okay. So let's look at this actual question. It says a pendulum 30 centimeters long. So we have a pendulum. The central thing. That is 30 centimeters long. Swings through an arc of 45 centimeters. Through what angle does the pendulum swing? So when I go to find this angle, what's it going to be in? Radians, every single time. So often if they give you the angle, they'll give you the angle in degrees so that you have to convert it before you can use it. Or they'll make you find the angle and ask for it in degrees because you're going to get it in radians and then you're going to have to convert it. So either way, be suspicious, you're probably going to have to do some conversions. The only way they don't make you convert it is if it's like a long convoluted question, like there's ones in your hand-in, where like one where they're cleaning off the snow, the windshield wipers doing that. Well, you're going to have to figure out the whole perimeter, which is a lot already, so they actually give you the angle in radians because they're nice about it. Okay, so remember that to use this formula we need arc length and radius. Well, we do have the radius because if you think about it, and sometimes if they give you just a piece of it, go around in the circle, right? Pretend that's a really good circle, it's not. So this is the what? The radius if that pendulum went all the way around, correct? So my radius is 30. And my arc length is 45 centimeters. And they have to be in the same units, because when they're in the same units, the units cancel, I'm left with radians, correct? So if one was in meters and one was in centimeters, I would have to do something about it. All right. Because if not, I'd be left with like centimeters per meter, which makes no sense. That's not radians. So theta equals A, 45 centimeters, over R, which is 30 centimeters. The centimeters cancel, so theta equals 1.5. And you could leave it like that. You could write it as 1.5 rads, and you could write it as 1.5 radians, or you could leave it as 1.5. Because if there is no unit on it, it is assumption that it is a radian. Okay? But if you like it better, you can write rads or radians if you so choose. Now they want it in radians and degrees to the nearest tenth. So if I have 1.5 radians, remember to convert, I'm either multiplying by 180 degrees over pi, or I'm multiplying by pi over 180 degrees. And remember, we want to do that not by memorization, but by understanding. I know in the end I'm going to multiply by some sort of fraction, so that in the end I have a degree symbol. A degree symbol that looks like a bell. Because I need an answer in degrees, true? So I want the degrees in the numerator, correct? So am I going to multiply by 180 degrees over pi, or pi over 180 degrees? 180 degrees over pi, so I need degree in my numerator, right? And we have to type that whole thing in because they want it to the nearest tenth. .9 degrees. We don't do significant digits in 30 decimal. We do rounding angles. I know science and math should get on board with each other, but they don't. So nearest tenth. Nope. I'll give you rounding rules. They'll say tenth, hundredth, whatever. So if they say tenth, how many zeros does a 10 have? 1. So it's 1 decimal place. The number of decimal places is the same amount of zeros that's in that word. So if it's tenth, tenth has 1 0, 1 decimal place. 100th, 100 has 2 decimals, or 2 zeros, 2 decimal places. Okay? They often don't do thousandths because you actually has to fit in numeric response box. And if you're doing decimals, we have the decimals in your numeric response, just so you know. The way that the numeric response goes, the decimals fall in column 2 and 3, correct? So you will have to start with a 0. So really, that's why they don't ask for thousandths, because you wouldn't have enough room to do it. Okay? You guys try B. We need to calculate the arc length to the nearest tenth of a meter. So as much as we agree that theta needs to be in radians, yes? Yes. We all agree with that. Then the test comes, and you guys slide into your degrees, and then your answer would be degrees per centimeter or something weird like that, which should be a hint that something is wrong. But you don't. You're just like, oh yeah, boom, the answer's there. Because do you think they'll have the answer to you putting a degree in by accident? They will. They 100% will. It's common error. The diameter, so the radius is 4 point what? There we go. And then theta equals 150 degrees, but I need it in radians. So I'm going to put the 180 degrees down here, the pi here, and we should get 5 pi over 6. Because we do not want, and look, the degree symbols cancel off. Oh, it's radians. Shocking. All right. We want to use 5 pi over 6 because we do not want to round until our very last answer, correct? Because if it's a numeric response and you round before the last answer, you may be off by a point. I know little lady in Edmonton's like, oh, this kid's a cute kid, I'm sure. You just sillily rounded before the end. I'm going to give it to, it's a computer with no emotions. Okay, it just goes like this. And then you mark. There's no heart, there's no love, there's no like, this kid bubbled it wrong. There's no like, this kid didn't put bubbles. There's no like, oh, there's 2 bubbles in 1 row. We should go look and see if they made a mistake because they bubbled all 4 bubbles in 1 row, which just happens. They don't. It's a machine. Some people accidentally, instead of 1, 2, 3, 4, will go like 1, 2, and then 3, 4. Like they accidentally just slide the bubble. You know, it's just an oopsie. So double check your stuff. Well, no one's going to be like, oh, I think they put the bubble below. It's a computer.
Are you saying the government doesn't care about us?
I believe the government cares. I think that you guys just have to not be stupid. So if like the answer is 1, 2, 3, 4, you have to go 1, 2, 3, 4. Not 1, 2, stacked. Nothing here. 3, 4. Like you shouldn't be getting tricked by a bubble sheet. Okay? That should not be what halts you from passing that 30 decimal. Okay? The bubble sheet should not be like the be-all end-all stopper of all the mathematics, right? Like it's just you just fill in your bubbles, right? I believe in you. Okay. So theta equals A over R. Multiply your R up. A equals, I should show all the steps. A equals 4.6 meters times 5 pi over 6. What's meters times nothing? Meters. That's good, because arc length should be in meters. Like if you use your units, it should hint that you screwed up or not. Like if you have meter degrees. Okay, so we want it to the nearest tenth, so 1 decimal place. So we go 4.6 times 5 pi divided by 6, and we get 12.0. Now, what if you round it to 12? And it's wrong because it says the nearest tenth. So 1, 2, decimal 0 is what the little computer program is marking you on. Yeah? Okay. Yes. You have to hold marking cursors. Same as this. Yeah, back on the same page. Okay, I want you guys to put number 16 in your hand in. Number 16 and try it.